54. All right, so we are doing exponential function manipulation. Okay? So you've done lots of things with exponential functions in the past. You know what they are. I'm pretty confident that you haven't done this type of manipulation before, but you are totally capable of doing it. So the properties of exponents that we learned in algebra can also be used for this. We reviewed these yesterday. These are just 3 of the ones that we talked about, the 3 that are going to come up the most in what we do. And remember that the biggest one here is that if I have this 2 to the x plus 3, that I understand that I can go backwards and get to this right here. Because most likely everything you've done has been going forward, right? You know to add the exponents, but you have to understand that you can split them up. Also, with the power to a power property, I didn't do any examples like this yesterday. We did them all like what shows here. This gives me this gives me this. But understand that I could also take this and end up with that. I can go backwards on any of them because it's still the same property. You're just using it in reverse. Okay? And then, of course, your negative exponents. So that's what we're going to do here. Right here, the first part, we're just going to talk about the transformations. A disappeared. And, you know, I use an Adobe editor to edit this stuff most of the time. And sometimes when I move stuff, things just disappear. I have no idea where it went. I did not delete anything, but I was trying to give you more space on stuff, and then I don't realize until after I've copied it that it's just gone. So this is what should be here. F of x is equal to 4 to the x plus 2 power. Okay, so that's the function that should have been there. And all we're doing right now is determining the horizontal transformations. So when you have exponentials, you know how we try to decide for transformations, does it affect x or does it affect y? In exponentials, way easier to figure out, because if it affects x, it's up in the exponent. If it doesn't affect x, then it's not in the exponent. That's the way it works. And make sure you understand also that the base of the exponent, which is 4 here, 2, 9, 5, does not affect that is not part of a transformation at all. That's part of the function. So all that's really happening here is that we have this x plus 2. So if I add 2 to x, I know that this is a horizontal what? What do you call it? What's the word? Translation. Thank you. Horizontal translation. And then which way are we going? Left, because x is a liar, right? I'm not going to write the word left. You can, but the way I've seen it written for you most of the time in the multiple choice questions, because this isn't something you're going to have to write out on the AP exam, but you do have to recognize their wording. Very rarely have I seen them use left and right, if it was on the real stuff, but they like to say of -2. So that's the way I want to write it for you, so you see it that way, because I think if it says left or right, you totally get that. But if it said of 2 and it doesn't say left or right, you have to know that that means that you're going to the right because it's positive. Okay? All right, everybody good with that? Alrighty, so then I look at this one here. I have 2 to the 3x power. So again, I know these are all horizontal, but I'm multiplying by a number, so it's a horizontal what? What's that word? It would be a stretch or compression, but what's the word that it takes for both of them? Dilation. Thank you. Dilation. Okay. Horizontal dilation by what? 1/3. Yes, I heard you whispering 1/3. 1/3 because x is a liar, right? So same transformations you've been doing forever. Then I have 9 to the x over 2. Well, we can either add and subtract or we can multiply. We haven't talked about dividing because technically you're not even subtracting. You're adding a negative when you do that. But I can rewrite this as 9 to the 1/2 times x power. Now that's written in a multiplication way that we can talk about it then. Okay. So do you have to rewrite it? No. Does it help? I think, yeah, absolutely. So that means this would be a horizontal what? Dilation, good. By what? 2, very good. Okay. Any questions? right? So then 5 to the x minus 1, this is a horizontal what? Translation of what? 1. It's a positive 1, means we go to the right. Any questions at all? Like that's all kind of old business, right? Okay, so now it says let's re-examine the exponential function in 1a, which is right here, the one that we tried to disappear, and see if we can use our exponent properties to rearrange the function into an equivalent form. So those words equivalent form, we've done that. We've had equivalent forms of a lot of things, right? Like if I put a line in y equals mx plus b, or if it is in point slope form. They look different, but they are equivalent forms because they give me the same function. That's basically what this is saying. So we're going to take that 4 to the x plus 2, and it says we can use the product property in reverse. So if I'm going to use this in reverse, then 4 to the x plus 2 is also equal to 4 to the x times 4 squared. Do you agree with that and understand why that's legal? Right? We're just going backwards. And so then you can say, all right, if I take this and go this way, would I end up with the same thing? And the answer is yes. So you can check yourself. Then we can clean it up a little bit more. 4 squared is 16, so I get 16 times 4 to the x power. So this means that when I had f of x equals 4 to the x plus 2 power, right, that's what we started with, is equivalent to writing f of x equals 16 times 4 to the x power. So those two functions that I wrote in purple are actually the same function. And one way to check yourself when we're doing this, if you do one, you're like, I don't know how those will be the same. Graph them both in Desmos. They should graph right on top of each other, and you've basically just checked yourself. Okay? Everybody good with that? Equivalent form. So I have taken, so what this means then, that's what we're about to say. So there is this should say longer. So no longer a horizontal translation, but now we have a vertical dilation. So here is the important idea. This is kind of the whole point of all of this. Every horizontal translation of an exponential function is equivalent to a vertical dilation. Every single one of them. That's not true for every function, but it's true for every exponential function. So this is kind of something special that happens with them. Here's a little visual for you. I didn't do it on the one we actually wrote out. But so this is 2 to the x. It's in blue. Okay, I know on yours you can't tell which is which, but it's in blue. And then, so it's still in blue right here. So if I do 2 to the x plus 3, that means I've shifted it to the left 3, and you can see that that's what happened with my red one. Make sense? Like you can just see, like, I can just move it over. Here, I changed it to instead, I don't have a translation of a vertical dilation. So again, I start with the blue one. Think about being like a piece of string, and I grab this, and then I can just like stretch it up. I could stretch it up and make it match the red one. Okay, and that's what's happening with your vertical dilation. So again, it's the nature of the function and how exponentials work, why that actually works for you. All right, so here we are going to write an equivalent representation that has a vertical dilation and no horizontal translation. Okay, so I have f of x equals 2 to the x plus 3 power. So I know that I can rewrite that as 2 to the x times 2 to the third. Everybody okay with where all that came from? Now, I will say, though, I realized on the examples that we did yesterday, going the other way, I had the bases were all variables. And one of the common mistakes I see is that if I have this and I'm trying to get it to this, is that you know to add the exponents, but then some of you also multiply the bases and end up with 4. That does not happen. The base stays the same no matter what, and you just deal with the exponents. So remember that. So then when I have this is f of x So I can clean this up. What's 2 cubed? 8. And then that's 8 times 2 to the x power. We okay with that? And then these two right here would graph the exact same function. Okay. So then we have g of x. So this will become 3 to the x times 3 to the negative 2 power. So that means g of x equals, well, what is 3 to the negative 2 power? 1/9, okay? And if you're not sure why, if I take, let me see where I can write this. So 3 to the negative 2 is the same as writing 1 over 3 squared, which is 1/9. Okay? So I have 1/9 times 3 to the x power. And yes, ma'am. So I could write this as g of x equals 1/9 times 3 to the x and not have parentheses at all. I could write it, I think what you're actually asking is like, would this be okay? Is that what you're asking? So that is not wrong and it would be okay. Would you see it like that if it was written for you on a test? No, you would see it more like this, just because you're really kind of grouping like, this is the thing I'm taking to the x power. Where when it's just a positive whole number, like I had right here, it's really technically not necessary, but I think it just kind of helps be consistent with what we do. So it's really better if it's on the outside. Does that help? And I know that, I put 1/2. It would be 1, but whatever. I was just, remember that under no circumstances are we going to multiply 1/9 times 3 or 8 times 2. Okay? I feel like it's maybe a little bit more tempting in this situation, but you don't do it, right? We can't because of I think it also helps you see it that way so you don't accidentally try and do something weird with your order of operations. Okay? Any other questions? That was a good question. Okay. Then we have this one. Now, this one, these are basically just b to the x plus h. This is, or x minus h. This is a times b, so like I already have an a out there. I'm not going to forget about the 4. I'm not going to do anything weird with the 4. I'm going to do all the things I know that are legal in math and not make anything more difficult or make up stuff. So the 4, he's just along for the ride. Put the little 4 out there. And then I'm going to change this part to 3 to the x times 3 squared. Because I'm splitting it up. So that means then that my k of x is equal to, all right, so I got to do 3 squared. What's that? 9. And then since that's just a plain old whole number, I can multiply it by the plain old 4. 9 times 4 is what? 36. And then that leaves me with 3 to the x power. All right, so now I have a little asterisk on D because we're really not following these directions. Basically, we're going to go the other way with it to show you that because you might have to go the other way. Now, first of all, can I reduce the 2 and the 32? No. For the same reason I can't multiply these two, right? There's an x on that, so I cannot. I know it's very tempting, but I cannot do that. I can, however, rewrite it so that it looks like 1 over 32 times 2 to the x. So if I'm trying to take a vertical dilation and change it to a translation, that means I need the a value, which is that 1 over 32, to be rewritten as some exponent of 2. Now, it may not be like, you wouldn't be asked to do that if that was 1 over 30 and you couldn't get a nice, pretty exponent. You're not going to be asked to do that by hand or anything. But I can. 32 is 2 to what power? 5. Okay. So I can, and I'm going to write this in a couple steps so I don't lose anybody. I can write this as 1 over 2 to the 5th times 2 to the x. Okay. Or it's also 1/2 to the 5th. That's another way to look at it, either way. But I don't need that to be 1/2 or 1 over 2. I need that to be 2 to some power. So I can rewrite that first part as 2 to what power? How do I make this into a 2 to what power? -5. Good. 2 to the -5th times 2 to the x, which means then I get that h of x is equal to 2 to the x minus 5 power. Okay, so we need to be able to go the opposite way as well. What questions do you have? Okay. All right, so now we're going to use the power property to look at some other equivalent forms. So if we use the power property of exponents, we can show that every horizontal dilation of an exponential function is equivalent to changing the base. So here's a visual for you. We start off with 2 to the x. And then if I do 2 to the 3x power, that is a horizontal dilation of 1/3, so that blue becomes red, it gets squished in, right? Or because I can rewrite this as, so we have 2 to the 3x power, right? I can rewrite that as 2 to the 3rd to the x power. Would you agree with that? That's like taking the power to a power and going backwards. And then that means 2 to the 3rd is 8. That's where I get 8 to the x power from. So if I have, the bigger your base is, the steeper your function is. So from the very beginning, it just kind of starts like that. Has the same effect on the function. They look completely different. They graph the exact same thing. Okay. Now these directions here. So before I print out your notes, I print out what I did last year, like my filled-in copy, and then I look to see where maybe I need to give you some more room, or I need to change things, or whatever. And I noticed on example 3, I had the instructions all marked out, and I was like, well, that's weird. I must have been talking and then changing them. Then I realized the second period as I was doing this, oh, I think I was a victim of copy and paste. These are the exact same directions as, well, not the exact same. It says each of the following has a horizontal dilation, which they actually don't because A doesn't. But either way, we're going to mark all this out, and our instructions are going to become find an equivalent representation, because truly that's what the directions are going to be. These would all be multiple choice questions. They would all be non-calculator, so although you could check yourself with a calculator now, you wouldn't be able to figure it out on a calculator later. And then you basically have to match what you have to what they were trying to get, and sometimes you can get more than one thing. So we'll just talk about how to make these work. So one thing, I'm just going to rewrite this another way is what I'm going for here. Well, I don't have a plus or minus anything in the exponent. I don't have the exponent isn't multiplied by anything, but I know that I can rewrite 9 as 3 to what power? The second. So 3 to the second to the x power. This is another reason why having that x on the outside is important, is I think a good idea, because then you can take what's inside and you won't get them all mixed up. So then my f of x would just end up being equal to, and don't square the 3 and get the 9 back, because then you're just going in circles, right? It's the same as 3 to the 2x power. Graphs the exact same thing. And how do you know what direction to go in? If you're just saying find, it's because there'll be multiple choice and you'll be able to match something up. Okay, so then I have b, and we can say that b, even though it's to the x over 2, I think I would like to rewrite that as 16 to the 1/2 times x power, and we'll make that equal to g of x, because I didn't give it a name. So if I have 16 to the 1/2 x power, I can rewrite that as 16 to the 1/2 power to the x power. And then what is 16 to the 1/2 power? 4. So that means that g of x could also be just written as 4 to the x power. Everybody okay with that? Could I have written this to, and here what we were trying to get at was no horizontal dilation or anything. I could write another equivalent form of this, because I could keep going, kind of. I mean, this is the answer we want for what the directions should have said. But I have other options. I could make this into 2 squared to the x power. Would you agree with that? Is that the same thing? So then I could say that g of x is equal to 2 to to the 2x power. So then in the end, this one, and this one are all equivalent. Okay, so you don't necessarily just have one other one, but what these directions were supposed to say is rewrite it without a horizontal dilation. So that's why that was our goal. If the question just said, write an equivalent representation and you had answer choices, this could be your answer or this could be your answer. They wouldn't both be there unless it said pick all the ones that work or something like that. But we all okay on that? So then we're going to take C and we're going to make it into something that doesn't have a dilation limit, because again, that's kind of what our goal really was. We'll call this one h of x. So this 4, once again, is just along for the ride. And I'm going to take that power property and go backwards, because then I can make this 3 squared to the x power. And then again, I don't want to multiply the 2 times the x, because then I'm just going in circles. But then h of x would be equal to 4 times 9 to the x power. It doesn't affect that 4 at all in this case. If there was a translation, then it does affect the number that's out there, but it just depends on what questions do we have? Anything? We all good with this? Notice how these are all the exponent rules you already know. So don't put it in your brain as a brand new idea, because you do know how to do this stuff, I promise you. All right, so let's look at number 4. Here it just says, which of the following is an equivalent form? It doesn't tell me like to not have a dilation or anything like that. So I could do this a couple of different ways. We're actually going to do this 2 different ways. So I could start off by saying, well, I know I can rewrite 9 as 3 squared. So I could rewrite that as 3 squared to the 2x power. Do you agree that that's the same thing? Yes? So then, I don't want to get on my squared, I'll be going in circles. Then I can say y is equal to 3 to the 4x power. Do you see how I got there from where we started? So I look over here, not an answer choice. I have a 3 to the x, but it's not 3 to the 4x, which makes me think really, truly, the answer, there's no way it can be A, because it would still have to be equivalent to that. But if you're not comfortable marking out at that point, that's okay. So we just have to go, okay, well, I have to go a different direction than this. Another option I have is to make this into 9 squared to the x power, which means I could get y equals 81 to the x. And that's this right here. Okay? What questions do you have? We good? All right, so we're going to work 5. Kind of the same, like, we don't necessarily know where we want to start. Here's what I know I don't want to do, though, is I don't want to try and get it into a translation. Well, first of all, because there's no translations over there as an answer choice. But if I did, like, let's just think about this. I could rewrite this as 3 squared times 4 to the x power. Would you agree that those are the same thing? Can I combine them and make it to the x plus 2 power? Why can't I do that? Because the bases are not the same, all right? So if the bases were the same, then I could combine them, I could get a translation. But the bases are not the same, so like I don't even, and if you kind of know that before you write that down, you don't even have to go down that road. But that's definitely not going to do anything for me. All right, so then I know that I can make this equal to 9 times 2 squared to the x power. Do you agree with that? And then, so this could be 9 times 2 to the 2x power. Which, if I actually looked at my answer choices, would be a little silly to go down that road anyway, because I kind of know what that base is supposed to be if I look at my answer choices. But that doesn't mean that they'll always all be the same. So I just want to, that's another equivalent form that could possibly be an answer choice in a question. But if I look at my answer choices, I go, well, all right, that base is 16. And so if I rewrite this, I can say I have 9 times 16. Now, if I'm trying to change the 4. 4 is 16 to what power? 1/2. It's the square root of it. It's 1/2. 1/2 power to the x power. Because 16 to the 1/2 is 4. So far I have an equivalent form. Do we agree with that? And then when I rewrite it again, I get 9 times, well, this is going to be 16. And then when I do a power to a power, 1/2 times x is either 1/2 x or x over 2 either way, which makes my answer C. Okay. What questions do you have? We all good? Awesome.